Conservation of momentum. The conservation of momentum states that within some problem domain, the amount of momentum remains constant. Momentum is neither created nor destroyed, but only changed through the action of forces as described by Newton's laws of motion. Conservation of momentum is mostly used for describing collisions between objects. It is a fundamental concept of physics along with the conservation of energy and the conservation of mass. Also, conservation of momentum applies only when the net external force is zero, while conservation of momentum principle is valid when considering systems of particles. This is the formula of conservation of momentum. M sub 1 stands for mass of the first object, M sub 2 stands for the mass of the second object, U sub 1 stands for the initial velocity of the first object, U sub 2 stands for initial velocity of the second object, V sub 1 stands for final velocity of the first object, and V sub 2 stands for final velocity of the second object. Example, a car of mass m sub 1 moving with the velocity of v sub 1 bumps into another car of mass m sub 2 and velocity v sub 2 that it is following. As a result, the first car slows down to a velocity of v sub 1 and the second speeds up to velocity of v sub 2. The momentum of each car is changed, but the total momentum p dot of the two cars is the same before and after the collision, if you assume friction is negligible. Another real-life example is the draws that you feel at the time of firing. Does friction affect the conservation of momentum? Yes, friction affects the momentum. As friction increases, momentum decreases. One way to keep momentum going is to have constantly greater goals. Michael Korda. Thank you!